A geometric series is a particular kind of infinite series. It has a special form. What a geometric series looks like is still an infinite sum, say from 1 to infinity, but has a form of some number a times another number raised to the n minus 1 power. So again, just to emphasize this a, that is just some number, as well as r itself, that is some other number. And a and r could be any real numbers. At this point, note, we haven't talked about if it converges or diverges, just defining all the characters in this series. So if we were to write out the first couple terms of this series, it would look like the first term, when n is equal to 1, we have a times r to the 0, or just 1, plus a times r to the 2 minus 1 for the next term, which is just a times r, plus a times r squared plus a times r cubed, and so on. And now this series has a special particular property. Every single term in this series consecutively gets multiplied by this common factor of r. So the terms just, as we go out in the series, keep getting multiplied by r. That is the only thing that's changing from term 1 to term 2 to term 3 to term 4 and so on. So we're going to ask ourselves a couple different questions at this point. The first question we're going to ask is, well, we haven't talked about any convergence or divergence of the series, but at this point the only series test we have at our disposal is the test for divergence. So we're going to ask the following question: what values of r could we hope make the series converge? Again, what values of r could we hope make the series converge? Again, I'm emphasizing the hope because we're just going to hit this geometric series with the test for divergence. And all this test for divergence could tell us is right up front if the series looks divergent. So if we apply the test for divergence, we take the limit as n goes to infinity of the series generating function, this a times r to the n minus 1. And well, what we actually can tell is if r is any number less than 1. So for example, if r is something like a half, and we take a half to some very, very large power, say the limit as n goes to infinity of 1/2. This limit's going to be 0. And we did a similar type of example when we first started talking about sequences. Now, if we have any other number, where say r is something greater than 1 in absolute values, say we have something like 3/2. If we raise this to the power n and take the limit as n goes to infinity, this equals infinity. So what we actually realize is for this geometric series, we have two different cases. If r is less than 1 in absolute values, this limit is going to 0. But if r is greater than 1 in absolute values, or equal to, this limit is going to infinity. So, in other words, for any hope that this geometric series converges, we need that this common ratio r has to be less than 1 in absolute values. So, the second question we want to ask ourselves is what happens, what happens if r is less than 1? But before we go there, I want to give you the big spoiler about geometric series. Basically, the spoiler is if we have a geometric series, the limit or the series from n equals 1 to infinity of a times r to the n minus 1, we see basically if r is less than 1, the series converges. Number 2, if r is greater than or equal to 1, the series diverges. And the third thing that's particularly interesting is actually if that common ratio r is less than 1, the series converges, but we know what it converges to. And interesting enough, what the geometric series converges to in this case is the following ratio. Remember, a and r are just some numbers, but this infinite sum of terms actually just comes out to a all over 1 minus r. And remember, this is only the case if r is less than 1 in absolute values. So 1 and 3 go hand in hand because they both have the same r less than 1 in absolute values. If the series converges, we also know what it converges to. And this is going to be something that's very special about geometric series. So when we ask the next question, well, what is special about r being less than 1? As we've seen before, all this says is a test or passes the test for divergence, but we're going to actually prove why geometric series converge in this case. Check out the next video.